Okay, equation with the variable and the exponent, it is an exponential equation. Okay, so we're going to take this right here back to what we were doing yesterday. All right, so first of all, we need to have what before we can move forward on any of these problems? The same what? Base, okay? So what are we going to turn 8 into? 2. So 2 to the what power is 8? 2 to the third. Is everybody with me? All right, so I'm going to make 8, 2 to the third to the x equals 2 to the 6th. Now we're going to apply our powers. So power to a power, what do? Multiply. So 2 to the 3x equals 2 to the 6th. So y'all, if you were to look again back at yesterday's notes, when you have the same base, your powers have to be equivalent. All right, so I can solve for x now by just setting my exponents equal to one another. So 3x has to equal 6. So x equals 2. Yes, ma'am. All right, so some of this is just knowing your basic base exponent rules. Like 2 to the third is 8. Okay, 27 to the what is 3. Or 23 to the what is 27, sorry. 3 to the third. So right here, I'm going to turn 27 into, right here, 27 is going to be 3 to the third. All right, so power to a power, we multiply. So I've got to do 3 times x plus 1. So what does 3 times x plus 1 give me? 3x plus 3. So now, again, I have like bases. So what can I do with my exponents? Set them equal to each other. And y'all, this is a variables on both sides of the equation. Move my x over. What is 3x minus x? 2x. Move my 3 over, so 1 minus 3 is negative 2. So what does x equal? Negative 1. We good? Yes, ma'am. All right, so what's your base going to be on letter C? 2. What's your base going to be on letter D? 5. Okay, and we'll talk about D in a second because you don't actually have to do that, but we'll get there. All right, so letter C, change 8. 8 becomes what? 8 becomes 2 to the third. Okay, so 2 to the third to the x. All right, 2 to the 7th is good. 4 becomes... oh, Lord. 2 squared, not 4 squared. 2 squared to the 9th. Okay? So 3 times x gives me 3x. 2 to the 7th times 2 times 9? 18. Okay, so now what do we do over here? Add them first. Yep. Okay, so 2 to the 3x is going to equal 2 to the 25th. Now we can set them equal. So we can say 3x equals 25. So what does x equal? 25 over 3. Okay? All right, so on letter D. Okay, so if you turn 25 into 5, you can do that, right? 5 squared, whatever. What else could you do first on letter D? You can move the negative. What else? What does that negative 3 go to? The x, right? Just the x. Why does it not go to the 5? Because it's not in parentheses, right? Okay, so can I get rid of the 5? Yeah, like if that said 5x equal 25, what would you do? Divide by 5, right? We're going to divide by 5. So now x to the negative 3 equals 5. All right, what can't I have that I have? A negative exponent. Okay, so let's move that down. So it's going to become 1 over x cubed equals 5. I haven't solved for x yet, though. I need to solve for x. Okay, I do a little switcheroo here. You can do it however you like. I do the little switcheroo where ultimately speaking, 5 and x cubed just switch places. Okay, so it's going to be 1 over 5 equals x cubed. Okay, I can math that out real quick if you need me to math that out, but it ultimately works every single time. Do I need to math that out? Everybody good? Okay. All right, so now how do I get x by itself? What? Cube root. Okay, so you can either write the answer as the cube root of 1 over 5, or how can I write that as a fractional exponent? 1/5 to the 1/3. And I will take either of those, unless it specifies sometimes. It may say, you know, not to have fractional exponents and so forth. Okay, but all right, are we good? So this is how yesterday applies to today. We need to know base, we need to know exponent rules and all that kind of stuff going into today. All right. Exponential growth and decay. Everybody likes it because it's in the calculator. All right, so exponential equations model situations of growth and decay. What is a major purchase you make in life that has exponential growth? Exponential growth. Like you buy it for one amount, and then after years later, it is worth a lot more. Your house. Okay, y'all, I kid you not when I say that my lake house is worth more than 5 times what I paid for it at this point. More than 5 times. Okay? What decays over time? Your car. Okay, the minute you drive it off the lot, it decays. All right? Little old Bambi messed up my car. It went down in value. It is fixed, but it went down in value. So, all right, so this growth and decay formula right here, the one on the left is the one that you're most familiar with. If y'all remember doing this with your rate and all that kind of stuff, yes, no, maybe so? Okay, all right, so let's just write out what all this is. A of t, okay, is your amount after time t. Okay, so like your A of t, if I ask you, you know, how much your house is worth after 10 years, after you get that value, that is your amount after 10 years. That would be your A of t. All right, A of 0 is our what amount? It's your initial, yeah. You're starting, if y'all said that. Okay, that is when the time equals 0. So for instance, the amount that your car is worth, or whatever is the amount you paid for it the day you bought it, okay? And then over time, that is going to depreciate. The amount your house is worth is whatever its value was on the day you bought it when no time has passed, okay? And then after time, it increases in value. All right? Our R is our what? It's our rate, okay? And that is going to be written, remember, as a decimal. So, just to reiterate, if your R is greater than 0, you have growth, and if your R is less than 0, you have decay. All right, and the last thing we have here is our T, which is our time. And normally this is in years for your general growth and decay formula. All right, so there's only, the second formula though might be kind of new to you. You may not have seen it before, but we talk about it in terms of growth and decay, not necessarily with a decimal rate. Like for instance, like for the first one, we normally say stuff like, oh, your house appreciates with, 14% a year, whatever it is. So your rate would be 0.14 and you would go from there. The ones like for the second one here is like if I tell you something doubles or something triples, okay? If something doubles or triples, or what we use later was a half-life, those things are going to be your base here. So if it doubles, what would your B? What would your B be? 2. If it triples, what would your B? 3. Okay, if I say something, is 5 times more over amount of time, that would be 5. Okay, so you're not doing 1 plus or 1 minus there. You're literally putting what is happening over the amount of time as your base. Okay, so same thing. A of t is still the amount of time after time t, the amount after time t. Okay. A of 0 is still our initial. Okay. B here, or T is still our time. Okay, and this can really be in any unit. You'll see today and in general, a lot of times, oh, sorry, y'all. You'll see in general today and a lot of times, a lot of this is based on like hours. Like you would do a lot of this in like chemical or biology type stuff about half-lives and things like that, about bacteria per hour, you know, things of that nature, because it grows or decreases exponentially a lot quicker. Okay, but it's per hour versus. Because you think about it, y'all, think about when you get sick. Like, y'all know whenever, like, it's flu season, right? It's flu season. Somebody gets the flu, right? They come to school. The next day, I got 6 people with the flu, right? The next day, what happens? It's like, yeah, but it's not like 1 more or 2 more. It's like exponentially more, okay? It happens that fast, all right? And then, so K is the one thing we don't know here that we haven't had yet. K, all right, is the time needed to multiply A0 by B. And I'll talk about that as we get into the problem. Okay, but ultimately speaking, if I say that something doubles every 4 hours, then your K would be 4. Is how long it takes for it to do that. All right? Everybody good so far? Just on our equation. So your equations are on the same page, correct? Like they're half pages? Okay, so y'all can still refer to them when we get to the second page. All right, here we go. Good stuff. Grab that calculator. Make sure you have it. You're going to need it. All right, in a certain city, the value of a house is increasing at a rate of 16% annually. Find the value of a $100,000 house in 4 years. All right, so which formula are we using here, left or the right? We're using the left. A of T equals our initial amount, 1 plus a rate because it is increasing to our time. All right, so what is our initial amount here? 100,000, right? 1 plus, what's our rate? 0.16, and they want to raise that to the 4 years. Okay, so A of 4. So the amount after 4 years equals 100,000 times 1 plus 0.16 to the 4th. Grab your calculator, type that in, let's see what we get. I don't have a calculator. There we go. Oh, we restarting. Okay. How's my battery low? What we got? One. All right, so we got 181,063.9. Why are we rounding to 2 decimal places? Because it is money. 181,063.94. Now, there are people that will argue about rounding versus not rounding. Okay, that won't be the issue on your test. Sometimes they say banks just cut it off. They don't round if it benefits them. If it benefits you, they do round. Okay, it's just back and forth. We're going to round because that's what we do in math. Okay. All right, how many years will the value of the house double? What you think? What do we need to do? What would the value of the house if it doubled be? How much? 200,000, right? So I'm going to put 200. That's my final. I want it to be $200,000, right? So I'm going to put that over here as my end. Oops, that's supposed to be an equal sign, y'all. Sorry. As my end game, okay? 200,000 equals, let's go to the same, 100,000 times 1 plus 0.16, and we don't know how long. It said how many years. Well, time is years, so T is what we don't know, okay? So let's go back to what we were doing earlier. What can I do first here? I'm ultimately trying to get T. What can I do first? How can I move that 100,000? I can divide by 100,000, right? So that gives me the 2. And I just went ahead and put the 1 and the 0.16 together. So 1.16 to the t. All right. Here's the way y'all are going to do this for now. There will be a way coming shortly in the future that we can do this differently. But for now, grab your calculators. This is going to go into y1, and this is going to go into y2. Let me see if I can get a different calculator, because apparently mine is not charged. Maybe I can charge it. Let's see. Maybe it'll let me use it while it's charging. Let me use it. Let's see. All right, let's see. Y equals. So 2 goes in the first one, and 1.16 to the x goes in the second one, right? We good? Hit graph. Boom. Do you see the intersection? Can y'all see the intersection on your, if you can't hit zoom 6. All right, we ready? How do I find the intersection? Second, trace what? 5, and then we just hit enter, enter, enter. Boom, there it is. So what is our number? 4.6702. Or 1, either way, 4.6701, 4.6702. So I'm going to say 4. Now, there is a way that we can do this. Do y'all remember in Math 3? What did y'all do when you were looking for an exponent? Do y'all remember what you used when you were looking for exponents in Math 3? I don't remember. Okay, ultimately, another way you can solve this is using logs. And I know you learned logs in Math 3, okay? I don't know how you applied them, so we will get to logs later on in here. But for now, we'll just do it this way, and that's fine. But one thing you can tell me, y'all, is if you were to put this into y equals, the second one, and look at our table, okay? We're looking for it to double, right? Everybody with me? Which was 2 for us, correct? Everybody with me? So if you look here between 4 and 5, does everybody see that? How it jumps from 1.8 to 2.1? So you know the answer is going to be somewhere between 4 and 5 years. Is everybody with me? Okay. How do I put my initial amount? Let me take this out. How do I put the 100,000, 1.16 to the x? Okay. How do I put that in there and hit the table? Okay. I would want it to be between, I wanted it to reach 200,000. So if you look here and here, again, you can tell 200,000 is between 181,000 and 210,000. So it's somewhere between 4 and 5. Now I can change my table to go in increments of like 0.1. And then I can, you know, oh wait, let's start at 4 and go to table start to 0.1. Okay, and I can look now, and now I'm a little bit better. I know it's between 4.6 and 4.7. Does everybody understand that? Okay, but it's just way easier for us to use that intersection that we know and get the exact answer. Everybody good so far? All right. Letter C. How much did the house cost 5 years ago if the rate of increase has been constant? So 5 years ago, what are we doing there, y'all? How do we write 5 years ago in terms of a time? -5, right? With 0 being our starting point, 5 years ago would be -5. So we're going to go a to the -5 equals 100,000. 1.16 to the -5. And you're just going to type that on the main screen. Like so. Hit enter. 5 years ago, that house was worth $47,611.30. This, my friends, is why you buy real estate. It's not that drastic, but right now it is drastic.
I tried to put that on my calculator and it says error.
All right, let me see what you got. All right, everybody good so far? Everybody with me? Okay, use the -5. So if you put this one instead of this one. I don't always know everything with the calculator, but I'll try. All right. Okay, we get. Okay. All right, example number 3. The table below shows the number of bacteria in a solution at various times the bacteria population is growing exponentially. How did the population change from t equals 3 to t equals 9? Now, y'all, there's a lot of things you can tell me here. What's the most obvious thing you can tell me from 3 to 9? What did it do from 3 to 9? Increased. Okay, we're like, oh yeah, it increased. Okay, you can tell me how much it increased. It increased by what? 620? Okay, that still doesn't give me a bunch of information. All right, I'm looking for a very specific answer here. So from 3 to 9, to grow from 260 to 780. Okay, everything we're talking about is multiplication today. Okay, rates and so forth, right? So from 260 to 780, anybody want to guess what that does? 260 times what's going to give me 780? How much? 3. So it does what? Triples. Yes, that is what we want. We want that it tripled. All right, so now they want us to find an equation. Okay, well, if it triples, which equation are we using? The second one, right? The right one. Is everybody with me? Our base is going to be a 3. Okay, so what do we know? They want us to use P of t. So I know my original equation was this right here. A of t equals A0 B to the t over k. That's my original equation that is on my other page, right? Okay, but they're using P of t, so I'm going to use P of t. So P of t equals, all right, do we know our A0? Do we know the very beginning amount when time is 0? No, we don't know that. Okay, but we know it triples. Okay, and how long does it take to triple? So we went from here to here, right? So the difference from 3 to 9 is 6. Okay, so we know it takes 6 hours for it to triple. Does everybody understand me? All right, so let's see. Whew, well, I've got 3 unknowns right now. I've got a P of t, a A0, and a t. Ultimately, what can I not get from here? What does it not give me here? It doesn't give me A0, right? But I can pick any of these right here, any 3, any ordered pair, and I can plug it in for P of t and t, and I can solve for A0. Okay? I'm going to pick a certain one. Anybody want to guess which one I'm going to pick? Why am I going to pick the second one? Because my time, what is my time? 6. If I put 6 right here, what happens to 6 over 6? Now I don't have an exponent. Okay, so that makes life a little easier. So I'm going to pick this one. So my P of t is 450. We don't know our A0, but we know 3 to the 6 over 6. 6 over 6 is 1. So 450 equals A0 times 3. So now all I have to do is divide by 3, and what is my A0? 150. So our initial amount here is 150. Is everybody good? So now we can write an equation, right? P of t equals 150 triples every 6 hours. Correct? So now it says, what will the population be after 1 day? So I go in, I put 1 in for t, right? What? Why not? Why do I put 24? T is in hours. That's what they do, y'all. Make sure you read. Okay, so we're going to do t is 24. So our P of 24 is 150 times 3 to the 24 over 6. What's 24 over 6? 4. Now, you're more than welcome to put 24 over 6 in your calculator. Like if you're doing this, right, we can do 150 times 3 to the 24 over 6. I would love for you to know that 24 over 6 is 4 and just type in 4. It would just make me a lot happier, okay? I'll just type in 4. Okay, so what is our answer? 12,150. All right. Everybody good so far? All right, so let's apply a little bit more of this. Same thing, just different example. Boom, 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 boom. All right, Value of a $24,000 machine decreased 9%. Okay, decreased 9% each year. Which formula are we using? First or second? The first. Okay, it decreases 9% each year. So we're going to go A of T equals what? What's our initial? 24,000. 1 minus 0.09. Make sure you put 0.09. Okay, to the T, and our T is in fact going to be 3. Okay, y'all, there's nothing that makes you do this next step for me, except for I just like it to look prettier. 1 minus 0.09 is 0.91. Okay, and it is 3 years, so I'm going to put my 3 there. Okay, type that in and see what you get. What we got? 18,000. 18,085 and 70 cents. Something along those lines. Yes, no, maybe so. So it is worth $18,085.70 after 3 years. All right. Letter B. How are we setting B up? All right. Why'd you put 12,000? It says half, about half of its original value. So this time we're going to put 12,000 on the left, and then everything on the right is going to stay the same, but we're looking for T, correct? All right, so when you divide by 24,000, what does that give you? 1/2, which is 0.5. So where is this going, y'all? Y equals, the left side is, or the first one is 0.5. And the bottom one is 0.91 to the T. Or to the X, sorry. See if we can see it. I think I can see it. If you're not sure, like I think I can see mine. It's kind of close over here. Okay. So you could always zoom. Let's see. I'm going to zoom box and see what happens. Let's zoom box like here. I like zoom box. See if that gives me my intersection. Yay, there it is. So second trace, 5, right? Enter, enter, enter. What's our answer? 7.3496. I always use 4 decimal places unless I tell you different. Years, months, what? Years. Are we good? Yes, ma'am. Okay. Dimensions, DIM. Yeah. All right, y'all read number 5 and see if you can set up. It's a half-life, so which equation are we using? See up here? Oh, that's not no. So if this, see how that's dropping, go up there, and get another one. See now that's not counting. And now once you graph it just means your plots were turned on, and sometimes your dimensions don't work when your plots are turned on. All right, which equation were we using? The second one. Okay, what is our B? If it's a half-life, what's our B? 1/2. Yeah. Okay, and y'all can write that either way. You can write it as 1/2 or you can write it as 0.5. It doesn't matter. But if it's a half-life, that's going to be our B of 0.5. And then 4 hours is our what? It's our K. That's how long the half-life takes. All right? Y'all, half-life, things of that, medication. If any of you ever desire to be a pharmacist, a pharm tech, anything of that nature, okay? Even a doctor, you've got to understand how medication works. All right? The way medication works is you take a pill, right? And that pill starts to disintegrate into your body, correct? Okay, it's not a certain, it's not a linear decay. All right, it is exponential. All right, it's in your body, and then after an hour, there's about half of it, and then about half of what's left, and half of that's not linear. That is exponential, okay? So that's why they tell you how often to take the medication, because they know how much of it is left in your body after so many hours. Not every medication is take every 4 to 6 hours. Some might be 12 hours. Some might be once a day, okay? We all know my anxiety medicine's more than once a day. So that's all right. I'm just kidding. It's really not. Morning and night. Okay, all right, so if there were originally 1,000 bacteria in the colony, how many remain after 18 hours? What's my equation?
1,000.
Uh-huh. To the 18 over 4. Is everybody good on setting that up? All right, plug that in. What'd you get? 1941. All right, anybody not with me? Okay, what is the hourly decay rate? Well, I know it's half every 4 hours, right? So then y'all like, oh, well, that's easy. That's going to be, was that like 1/8? No, it's not. I mean, we like to think it is. It's not quite that simple, okay? So here's the thing. This is our rate every 4 hours, okay? We're going to combine our two equations to figure this answer out, okay? So let's look at the first equation we had, which was A of t equals A sub 0 times 1 plus r to the t, correct? Our second equation is A of t equals A of 0 b to the t over k, right? Okay, what do you notice is the same in both of these? AT and A0. So we're not really worried about that part. I'm worried about this part in both of them. All right. What one do I currently have? I have it written in which form? The right, correct? The 0.5 to the, what is it, t over 4 technically for us? 0.5 to the t over 4. Okay, so I have this. All right, so we're going to go back to yesterday when everybody had so much fun, right? Yesterday to our exponent rules, okay? Notice here our exponent is a fraction. Here our exponent is just t. So what is different from here to here? The divide by k part, right? Well, how can I turn that? How can I just have a t on the outside?
So move the k to the outside of the bracket.
And make it a, you could. Y'all remember this rule right here? Like if I had x to the 5th to the 2nd, what do we do there? We multiply, right? So what can I multiply t by to end up with a k on the bottom? I want a k on the bottom. Can I just multiply by k? That would give me tk. I don't need tk, I need t over k. What? 1 over k. So I can move this like so. Is everybody with me? But what is our k? 4. So I can make this 1 over 4. Now, look right here. Somebody type in your calculator. What is 0.5 to the 1/4 power? Do what? 0.840, we'll say 8409. Yeah, we'll say 8409. Everybody with me? So 0.8409 to the t. Yes, no, maybe so. Is everybody with me? Okay, now I need to turn that into what was my rate. Okay, if you had me for Math 1, it was really simple. We always take whatever's inside and subtract 1 from it. And that gave me negative 0.1591. The negative just means it's decay. We know that already. So if it's 0.1591, then what is my percent? Close. Leave it like this. 15.91% decay. Hourly decay. Now, had you put 16, I'd probably give you credit. Because if you'd have made 0.8409 into 0.84, then you would have gotten 16. All right, we good? All right, last thing, easy enough. Makes all of this way simpler is just something called the rule of 72. Okay, y'all, the rule of 72 is the easiest rule you're probably going to learn all year. Okay, the rule of 72. If a quantity is growing at R% per year or month or week or whatever time they have, then the doubling time is approximately 72 divided by R years or months, weeks, etc. The doubling time, okay? So where was that one? Let's see, it was... All right, so if it's 9% per year, everybody with me? All you're going to do is take 72 divided by 9, and our answer is 8 years. And then 12% per month would be 72 divided by 12, which is 6 months. Okay, that is, but it's only a doubling time. Okay, only a doubling time. And it's only if it is growing at R%. Okay, so like when you look back up at example 4, example 4, right? It said how long would it be half? That wouldn't work. But I think, where was the other one? The other one we did. Oh, like example 2, right? Yes, no, maybe so. Okay, so that one was to find out your time there. It was growing, doubling by 16%, right? And look, what was our answer to number? What was it at? What was our answer? Yeah, our answer was 4.6, right? On number 2, example 2, the amount to double. If I did 72 divided by 16, which is our rate, right? What do I get? 4.5, pretty close. Okay, so it's just a general idea rule. All right, everybody good on your notes?